So I'll go ahead and get started. One, if you're here for solving the energy crisis, I can't quite do that for you. Was a little blip in data that I sent over, and I'm not totally going to go there. But one, I will say Happy Pi Day. I have been waiting all day for somebody to say that, and I was just sitting at a table, and I heard somebody say that, and I was just like, 3.14. It's like, I won't go very far. My 12-year-old can, but I can't. But I'm like, why aren't we doing more for Pi Day? My name is Mauri Whalen. I work at Ampere Computing. How many people here have heard of Ampere Computing? You read it on the poster when you came in. Today I get to talk with you about what I actually love to do. I'm a vice president of software engineering at Ampere Computing. I've been there just short of a year. My background is I've been working in the tech industry for over 2 decades. I predominantly, probably for the last 15 years, have been working in open source, heavily into Linux kernel virtualization. I'm a big advocate of open source and collaborative ways that we can do development. And again, today I get to tell you about the future is open in the company that is running parts of the cloud. And that even is one of the things that I love about what I do is, working with software engineers, what do you like to do? You like to see your code out running somewhere and running parts of the lives that we live in. And there's extreme gratification to that. But I didn't try this yet. So who are we? Who is Ampere? We are a company that does microprocessors. We design and deliver high-performant microprocessors. Energy efficient, scalable, flexible, compatible. And the markets we're going after are both toward the cloud and on the edge. I'll go over more later. I went back and I did a lot of investigation before coming to the Open Compute Project Summit because I haven't been here before. And one of the things that I found was what they have right on their main website. The Open Compute Project is reimagining hardware, making it more efficient, flexible, and scalable. And this was extremely resonating to me. And I further went and I started looking at some older videos on the OCP project and trying to figure out what's the whole history of OCP. Where did it come from and what makes it tick? Not that I had never heard of it, but I just had never been exposed to it as I am here today. And I went back and I found a video from 2011, and it was a bunch of Facebook's engineers. And we know that they were some of the first people to contribute to OCP. And it was really enjoyable watching these Facebook engineers because what they were tasked to do was to go make things more flexible, more scalable, and more efficient. And one of the things that they said that also really resonated was they were also out to make efficient compute. And I'm like, efficient compute. I absolutely love those words. I'm going to start using those words. And it really drives efficient compute is what makes the best economics for the industry that we're in actually possible. And we at Ampere, this is every word that also resonates with us. And we really think along those same lines. We are growing a company to deliver scalability, efficiency, compatibility, high performance, more cost of ownership. We understand what's important. And to that end, one of the things I want people to realize is our timeline and the incredible momentum that has happened over the last 1.5 years for Ampere and where we're actually going. So in 2017, Ampere was launched. Launched as a very small company with great vision and really started massing incredible technical talent. We have some of the best designers in the world with very, many years of in-depth knowledge of this industry. Renee James is our CEO. After that, one of the things that is important to me is we launched a developer program. You're going to make hardware. You need to make sure that you give people the tools to actually use your hardware. And I'll come back to this particular point in a second because it's near and dear to my heart. Then we launched what our product was, Ampere eMag, 32-core ARM v8 architecture. And then it kept getting better. We partnered with Lenovo and did a launch of it's a shipping product today. It's in our booth. You can see our production hardware. And having strong partners like Lenovo is key to us driving Ampere into this industry. And then it got even better. We're also doing a product that started shipping just last month with MyTac, white box systems. And we keep growing. We also know it's important to make sure that we have a competitive roadmap, and we're doing several proof of concepts with cloud customers and other stakeholders for our hardware. And going one more farther, it's like, where are we going? We do have a very innovative product roadmap. We are driving towards 7-nanometer technology, single socket, multi-socket systems. You need to deliver world-class servers with world-class capabilities. The amazing amount of transformation that the cloud keeps going through for things like AI, big data, storage, it doesn't stop, and it's not stopping, and we understand the need for keeping the momentum in that strong, innovative roadmap. One thing I want you to take away from this, though, is look what we've actually been able to accomplish in an extremely short period of time. It's kind of exciting to go to work every day. Sorry, that wasn't supposed to happen. The thing that I want to get back to is the developer program. So there's been a lot of FUD in the news lately on, hey, is architecture actually available for developers to use? And I'm here to definitely tell you yes. Off of developer.amperecomputing.com, there is a Buy Now button, and people are able to purchase a production system for developers. It's not for general mass deployment, it is a developer system. Further, what's really important to me about this developer system is, again, you make hardware available to people to use, and they are only going to be innovative and creative for as much as they actually know about your hardware. And so off of the developer website, we have put, for example, our compiler. So not that we're not out in GCC and contributing to the GCC community, but because of release cycles, we want to make sure that our fixes are available before a formal release actually happens. So we have put our compiler out there. And there's tools, there's documentation, and there's also places where people can come and actually talk to us and engage with us and ask questions. Extremely important. And then we go, okay, so you're making a great product. Why are you in this industry? A lot of you, I'm sure, have seen various data slides. What business are you in? And this one is pretty darn simple, but it's easy to read, and it's easy to showcase that the semiconductor industry is a $450 billion industry. And there's growth. It literally just keeps growing. Of this $450 billion, the server market is approximately $16 billion. And we at Ampere, we understand that where that growth is coming from and really engage with partners and stakeholders in the ecosystem, so we know what we're putting together on our competitive roadmap. We know where we're going. Again, some of the growth that gets driven here, right, is when you look at the amount of machine learning and AI and storage and all the different solutions, which I'll go over in a little while, are happening. We understand why we're in business. I look at my job, again, I'm running the software team, as there's pillars to success, and one of my jobs is to make things easy for people. And this is where I really look at what OCP is all about and what standardization and compatibility is all about. And I want to drive into what I consider 3 pillars of success in this area. One of them is infrastructure, and this is hardware infrastructure. When you're looking at, you are making a piece of hardware, a server, going into a data center, you better be standard and not a one-off so people don't have to go change your rack size. There are very simple things and there are very complicated things in this area. The next part is open source. No doubt, I have been within open source communities for quite a long time. I know the value, I know the benefit. And I also know that from where I sit, I'll just give you an example. I want to go and I'm testing some kind of workload, or I'm testing doing some kind of benchmark. And I'm like, oh, this particular area, I actually need to make sure that it's ported to ARM, and I actually need to make sure it's optimized and tuned. That community, they're running off to the races based on what they have, right? So it's my job to always make sure that the communities that are running the cloud do have access to us, to have access to our hardware. Otherwise, those communities just go off without us. And then finally, open standards. And what I mean by open standards, because it kind of flows through all the other 2, is when you're looking at something like firmware. So ARM last year, about the October timeframe, did announce their ARM Server Ready program. And they do have standards based on boot and based on firmware. And they also have what's called an ARM compliance test. And we are seriously invested into making sure that the compatibility and the standardization is baked into our hardware and baked into our software solutions. Diving into this a little bit more, it's the expanding ecosystem that we at Ampere, we get and we understand it. The first thing, again, is hardware. We're working with Lenovo. We're working with MyTac. For our current generation, we do have also an evaluation kit. We have our developer system. And this is going to be important as we keep moving forward into that competitive roadmap, that we are continuing to follow standards, such as, there's things out there, the Mount Olympus project, right? Specifications we take very seriously. The next area, I call it IHV, your independent hardware vendors. So how do you get something on an AVL, approved vendor list? Why is that important? There are definitely, I would think that I would say the peripherals and a lot of the chipsets already are doing a really good job adhering to standards. And we think that's really important, that if somebody comes to me and says, hey, I have a new NIC, can I throw it in your system and will it just work? I don't know, do you have ARM ACPI compliant drivers? And all of a sudden those standardizations and those questions start coming. And we're really committed to making sure that we're playing with the ecosystem and we're working with our stakeholders and partners so things do just work in this particular area. And then we go on to the OS and firmware. So from an operating system point of view, most of the, if not, actually I would pretty much say all of them, the Linux operating systems have been ported to Arch64. And one of the things that we do, and my team is seriously invested in, is making sure that these operating systems, we have literally continuous integration, continuous regression suites running on our hardware all the time. We really think it's important, and I think it's important. One of the things that I'm notorious for saying is when you have your hardware come into your BIOS and your operating system, nobody should have to actually worry about that part of it. Go explore amazing, innovative, creative solutions in your middleware and your applications. Not that innovation doesn't happen to that left-hand side, but let's make it rock solid and stable. So we are involved with major Linux operating systems and have partnerships to run their hardware, and definitely continuous regression suites going on. We also are involved working with AMI, on AppDOV, MegaRack BMC, and starting to get involved in the OpenBMC and the Tiana Core EDK projects. Again, those are really, give me the NIC, is UEFI going to identify it? Is it going to be able to enumerate it? These questions we think about every day, and we're making sure that we're putting process and implementation and working with partners in place to make that happen. It really keeps things efficient and scalable. And the last area, debated if I should use this word, but I'll use it. I call it the monster in the middle. From my point of view, when you're working, I'm working with ARM server, V8 technology, I look at the amazing amount of middleware, and then I look at the amazing amount of applications on that middleware, and there are millions, if not billions, of combinations that you can actually throw together. And like CRUD. Every day, somebody comes and asks me, hey, Mauri, does OpenStack run on your platform? And what kind of combination? Because OpenStack is complicated in any ways you want to configure it anyway, right? And I do know, by the way, that OpenStack runs phenomenally well on Arch64. But as you can see, there's just too many configurations and too many ways to make this tick. So what I'm trying to do at Ampere is bring out that middleware, right? You have the applications at the top, and the applications, you could somewhat say they're hardware agnostic, except for most of these applications are tied into a piece of middleware, a MySQL database, a Redis database, right? And it's this database that then is going into talking to the operating system that is then going in and talking and using your hardware features. And so I'm pushing really hard right now to really take out what I call that middleware, the monster, right? If I can get that right and keep driving and pushing ourselves into the community, we're ending up in really great shape. And I can tell you that Ampere is committed, and what we are doing is we have engineers that are working in open source communities and open source projects. Definitely contributing to GCC. Can't have a silicon company if you don't have a compiler team. We're definitely, we have people going after OpenJDK. It's really important that any version of OpenJDK that gets released, I want to make sure that it doesn't regress and it works phenomenally well on our hardware. So really important to me to provide the tools, provide the people, because anytime you go work with a open source project, right? You go up and you ask them a question, they're like, hey, why don't you come and contribute that? I'm here to tell you we are really starting to get ourselves planted into this industry. So what I want you to know is at Ampere, we're committed. We're driving an aggressive roadmap. We've launched product. We've hired a team that has incredible depth and expertise in this industry with knowledge that we're going to keep succeeding. We've already delivered product in such a short, we've been in business for 1.5 years. Aggressive roadmap also means that you're going to start seeing us more with 7-nanometer technology, with the multi-socket, with the single socket. It's right around the corner. It's coming. We also know what it takes to immerse ourselves into industry technology. The cloud operates as a system. It's not just a microprocessor company. It definitely operates as a system. And that's what we're really driving. And that's what I get to wake up and do every day, is deliver technology that runs the cloud that I use every day. And with that, I will definitely say thank you. Thank you for your time. I'm around if anybody wants to talk to me. I noticed there's some other people from Ampere sprinkled in the audience. We do have a booth at B12. And at B12, there is production hardware there. There's a 1U and a 2U Lenovo box sitting in there. We have various demos running. And welcome going to the booth and talking to us too. And I thank you for your time and enjoy OCP and Pi Day. Thank you.